Today's topic of presentation is ASIC, FPGA and CPLD from Chapter 1 Advanced Digital Design and ASIC FPGA CPLD. Subject VLSI 22062. Before moving to the main topic ASIC, we'll brush up few things, that is about the integrated circuit. As everybody knows about the integrated circuit, an integrated circuit is a small, low-cost electronic circuit consisting of active and passive components fabricated together on a single crystal of silicon. The active components are transistor and diode, and passive components are resistor and capacitors. So everybody knows about the integrated circuits. Here you can see integrated circuit package, one package type. The first one is a pin grid array package, and the second, the silicon die or chip, is under the package lead. So that the package, different types of packages are available for integrated circuits, as you know. And one package of a dual inline package, which is available in our laboratory, you must have seen. That is the different types of logic gates. So that black color IC package, that is dual inline package of the integrated circuit, and you can understand that the whole circuit is inside the small IC. So that is the best thing about the integrated circuit. The integrated circuit can be classified in various ways. The one of this classification is small scale integration, SSI. Here you can understand that in this type of integrated circuits, number of logic gates available will be between 1 to 12, and the number of transistors which can be manufactured, can be formed inside, is 1 to 10. So that category of integrated circuits come in small scale integration. The second category is medium scale integration, and in that you can find key total number of transistors which can be fabricated inside the integrated circuit is 10 to 500, but number of logic gates which can be fabricated is 13 to 99. Then comes large scale integration. So total number of transistors can be from 500 to 20,000, and number of gates that can be fabricated is from 100 to 10,000. Then comes VLSI, very large scale integration. Here we have to emphasize on the number of transistors which can be manufactured or fabricated inside the IC is 20,000 to 1 lakh, and the total number of logic gates can be 10,000 to 100,000, that is 99,999. Then comes ultra large scale integration, that is from 1 lakh and more number of transistors can be fabricated, and the total number of logic gates which can be fabricated is 1 lakh and more. So here you can understand, as the integrated circuit goes on, as the integrated circuit goes on, so the year by year the number of gates can the manufactured inside a small IC is going on increasing. And now today in this topic we are going to emphasize on VLSI. Also the ICs can be categorized, or the different IC technologies are also there. So depending upon the IC technology, we can classify it as bipolar technology, IC technology. So in this IC technology, the transistors or BJT is used, or is transistors are manufactured using BJT. That means the logic gates will be formed using bipolar technology or BJTs, bipolar junction transistors. So this is one sort of IC technology if BJT is used inside the IC for manufacturing of the logic gates. Else if MOSFETs are used, then it is MOS technology. So in these ICs, the different gates will be formed using MOSFETs. Then comes CMOS technology, IC technology. In this ICs, complementary MOSFETs are used for the manufacturing of for the formation or the fabrication of the ICs. And then the next one is BiCMOS. So here a combination of BJT and complementary CMOS, complementary metal oxide semiconductors, are used inside the ICs for the manufacturing of the logic gates. So now the topic here is VLSI. So now we have studied about the in VLSI technology. So as we know that VLSI technology is nothing but the integrated circuit technology, one sort of. The VLSI is the one of the most widely used technologies for microchip processors, integrated circuits, and the component designing. It was initially designed to support hundreds of thousands of transistor gates on a microchip, which as of to 2012 exceeds several billions. VLSI technology is a process of creating an integrated circuit by combining thousands of transistors into a single chip. So we have already seen that in the last table. All these transistors are remarkably integrated and embedded within a microchip that has shrunk over time but still has the capacity to hold enormous amount of transistors. The first 1 megabyte RAM was built on top of VLSI design principles and included more than 1 million transistors on a microchip die. So VLSI began in the 1970s when complex semiconductors and communication technologies were being developed. The microprocessor is a VLSI device. Before the introduction of VLSI technology, most ICs has a limited set of functions they could perform. An electronic circuit might consist of CPU, ROM, RAM, and other glue logic. VLSI lets IC designers add all of this into one chip. Because of this VLSI design concept, there are a lot of advantages of the VLSI. So you can see that as many logic circuits are induced or is fabricated on a single small chip, so therefore it reduces the size of the circuit. The second advantage is reduces the effective cost of the device, of course. Then increases the operating speed of the circuit, requires less power than discrete components, high reliability, occupies a relative small area. VLSI applications. So there is a wide application of VLSI, as VLSI technology can be used for analog signal as well as for the digital signals. So it can some ICs which can detect the analog signals, and some ICs which can detect the digital signal. So one is digital IC and one is analog IC. Now it is concerned with forming a pattern of interconnected switches and gates on the surface of a crystal of semiconductor. So some of the main important applications of VLSI, as you know, as a microprocessor, personal computer, microcontroller, then you have memory, DRAM, SRAM, special purpose processor, ASICs, CD players, digital signal processing application, optical switches. So all these things has made highly sophisticated control system mass producible and therefore cheap. So basically we can say that in today's world, VLSI chips are widely used in various branches of engineering. So everywhere we need VLSI, we are using VLSI. So that is voice and data communication networks, digital signal processing, computers, commercial electronics, automobiles, medicines, and many more. With increasing VLSI technology, it has advantages to design an IC that was customized or tailored to a particular system or application rather than using standard ICs alone. Now the standard ICs are the ICs which can perform a single function. For example, like your NAND gate, it can perform only NAND gate operation. So that IC is specifically only it can perform and give the output of the NAND gate. That is the standard ICs. Now the ASIC stands for application specific integrated circuits. It means an integrated circuit designed for a specific application. An application may be microprocessor, cell phone, modem, router, etc. Nowadays ASIC has a complete system on it, often called as system on chip, that is SoC. So different types of ASIC are shown here, the classification of the ASIC. So the ASIC can be classified as full custom ASIC or semi-custom. And in semi-custom you have standard cell based, gate array and programmable ASIC. So in that programmable ASICs you have PLD, FPGA. In full custom ASIC, the primitive logic function of the transistor is manually designed and optimized. So everything work is designed by the designer. Everything has to be done by the designer. That is manual designing, optimizing, everything. Manual manipulation of each transistor geometry is also done, so called polygon pushing. Rarely used today except for very high volume products like microprocessor. Advantages: it gives most optimized design, high speed, low powers, small gate count. But disadvantages: long design cycle, productivity is low and high cost. Now the next ASIC is standard cell based ASIC design. Now as you can see here, in this design methodology, a predefined library cells, that is NAND, NOR, flip-flop, RAM, etc. are made available to the designers. The library contains gate level primitive and or NOT, etc. to complex functions like adder, multiplier, ALU, etc. Designs are created using schematic capture tools or synthesis from hardware description language. Now here the hardware description language is used. All mask layers are customized, transistors and interconnect. The advantages of standard cell ASIC: short design time compared to full custom cycle. As in as in this only. The second advantage of standard cell ASIC is mega cells or hard IP cores like microprocessor, MAC memory, etc. provided by vendor can be used easily. Disadvantage: separate fabrication mask is required for each design. High cost compared to gate array. The gate array ASIC. Gate array is widely used approach for the design and manufacture of ASIC. Gate array circuit is a prefabricated chip with no particular function in which transistors, standard NAND or NOR logic gates and other active devices are placed at regular predefined array positions and manufactured on a wafer, usually called a master slice. Creation of a circuit for specified function is accomplished by adding few layers of metal interconnects on the top of the master slice late in the manufacturing process, joining the elements in the array cell to allow the function of the chip to be customized as desired. The gate array master slices, usually in several families containing different number of logic gates, are prefabricated in large quantities regardless of customers' orders. The design and the fabrication according to the individual customer specifications may be finished in shorter time compared with a full custom design because there is no need to design the low level mask for the transistor. The gate array approach reduces the mask cost because fewer custom masks need to be produced. In addition, manufacturing testing tool lead time and the costs are reduced since the same test fixtures may be used for all gate array products manufactured on the same die size. The purpose of PLDs permits elaborate digital logic design to be implemented by the user on a single device. It is capable of being erased and reprogrammed with a new design. So different types of PLDs are, one category is simple programmable logic devices. So in that you have ROM, that is read only memory, programmable logic array, that is PLA, PAL, programmable array logic, and GAL, generic array logic. The next category is CPLD, complex programmable logic device, and then is FPGA, field programmable gate array. Simple programmable logic devices are the simplest, smallest, and least expensive form of programmable logic devices. SPLDs can also be used in boards to replace 7400 series TTL components and OR and NOT gates. The first three varieties are quite similar to each other. They all have input connection matrix which connects the input of the device to an array of an AND gate. They all have an output connection matrix which connects the output of the AND gates to the input of OR gates which drive the output of the device. So it is like this, an array of gates. So there is an array of AND gate, array of OR gate, and there is an array of input devices, and there is AND array connection and OR array connection blocks. So here you can see programmable logic arrays. So in PLAs, the array matrix which we have seen now, so here you can see in PLAs that array matrix AND gate array is programmable as well as OR gate array is also programmable. So both are programmable. So programmable logic array is a kind of programmable logic device used to implement combinational logic circuits. So it can be combinational logic circuits can be implemented using PLAs. PLA has a set of programmable AND gate planes which link to the set of programmable OR gate planes which can then be conditionally complemented to produce an output. Programmable logic array of PLA is used to implement logic functions in digital circuits. The structure has programmable AND matrix, programmable OR matrix, input and output buffers. Block diagram of programmable PLA device is as shown here. Now in this diagram you can see programmable read-only memory, PLD. So the AND gate array is fixed, so you cannot do any changes in that. You cannot, but OR gate array is programmable. So that means AND gate array is non-programmable and OR gate array is programmable. And in PAL, programmable array logic, AND array is also programmable but OR array is fixed. And in PLA, AND array is programmable and OR array is also programmable. FPGA and CPLD. The full form of FPGA is field programmable gate array and CPLD is complex programmable logic device. FPGA and CPLD is an advanced PLD, programmable logic devices. It supports thousands of gates whereas PLD only support hundreds of gates, and therefore FPGA and CPLD has advantage over simple programmable logic devices. So this is the general block diagram of CPLD. Here you can see there are blocks of PLDs and which can be interconnected, as well as you have input block and output block as well, input output blocks. So it is having complex PLDs is having many PLDs, and that PLDs can also be interconnected with each other. CPLD is Very important. It is one kind of integrated circuit that application designers design to implement digital hardware like mobile phones. So this can handle knowingly higher designs than SPLDs. SPLDs are a simple programmable logic devices. CPLDs include numerous logic blocks. So each block in CPLD includes 8 to 16 macro cells. Every logic block executes a specific function. All of the macro cells in a logic block are fully connected. Depending upon the use, these blocks may or may not be connected to one another. Most CPLD have macro cells with some logic functions and elective flip-flop. So this is one CPLD of company Ultra Max. It is a complex programmable logic device IC. Now the next is a field programmable gate array. It is also called as FPGA. It is a chip whose final logic structure is directly configured by the end user. Since IC fabrication is eliminated, cost is effectively reduced. Field programmable means that FPGA function is defined by the user program rather than by the manufacturer of the device. The FPGA's function is defined by a program written by some other than the device manufacturer. Depending on the particular device, the program is either burned or permanently or semi-permanently as a part of board assembly process, or it is loaded from an external memory each time the device is powered up. This user programmability gives the user access to complex integrated circuit designs without the high engineering cost associated with application specific integrated circuit. This is the architecture of the FPGA. Here you can see the input output, the logic block with blue color and the input output pads with the pink color, and the lines, row wise and the column wise, which is the lines which you can see is nothing but the routing channels. And this routing channels are nothing, there is a programmable switch there for the connection of the blocks. So this is the application of FPGA. So in digital signal processing, there is a wide application: software defined radio, aerospace, defense system, ASIC prototyping, medical imaging, computer vision, speech recognition, cryptography, bioinformatics, and others. There is a wide application of FPGA. Advantages of PLDs: programmability, reprogrammability. PLDs can be reprogrammed without being removed from the circuit board. Low cost of design, short design time, immediate hardware implementation. The design inside the chip is flexible, so change in the logic does not require any rewiring of the board. Decreases PCB real estate, less space than multiple standard logic packages. Improved reliability, fewer packages, fewer external interconnects. Thank you.